Okay, now there are two types of series that we're going to look at, and the first type is called an arithmetic series. We're in exercise 8.4. Now, in an arithmetic series, each term is a constant amount more than the previous term, and the constant term is called the common difference. For example, the common difference here in this series, we can see that the series is going up by 2. So the common difference, actually, we call the common difference, we call the letter D. So the common difference D is 2. But I don't want to just write what that is. We're just going to, so I'm just going to put, sorry, here that the common difference is 2. Now this is term 1. This is term 2. This is term 3. This is term 4. Now what we notice is if we look at, to do the common difference, you need to do one term minus the previous term. So if I go term 2 minus term 1, that's 6 minus 4, which is 2. If I do term 3 minus term 2, that's 8 minus 6 is 2. And if I do term 4 minus term 3, that's 10 minus 8 is 2. So the formula for working out the common difference, so common difference is that. So just a little rule here. So if T1, T2, T3, etc. are consecutive terms, so if T1 to T3 are consecutive terms in an arithmetic series, then the common difference D, so I can write that, so then the common difference D is equal to T2 minus T1, which is equal to T3 minus T2, and so on. Okay? All right. Oh, actually, there's no and so on because I'm just talking about the first three terms. So the common difference is T2 minus T1, which would be also the same as T3 minus T2. Now another example, so this series is going up. I'll look at a series going down. Let's say we go, we look at the series 10, 5, 0, minus 5, etc., minus 10, etc. Let's go. Okay, so we can see that each term is going down by a constant amount, which is down by 5. So if I want to work out the common difference, it's T2 minus T1, which is 5 minus 10, which is negative 5. And if we look at T3 minus T2 as well, that's 0 minus 5 is negative 5. Remember, this is T1. That is T2. This is T3. That is T4, etc. I can do one more. T4 minus T3 is negative 5 minus 0 is negative 5. T5 minus T4 will be, I'll do that one again as well, because it's negative 10, take away negative 5, which is, so this one's T5, which is negative 10, minus T4, which is negative 5. So it's negative 10 plus 5 is, again, negative 5. So therefore, we can see the common difference is negative 5. Now, of course, you don't have to do that many, but I did that many because we're getting into the negatives here, and I just want to show you if you did have a negative, if all your terms in the series were negative, how you would do the common difference, how you would evaluate, work out the common difference. For example, if x plus 3 plus 2x plus 5, so that's T1, this is T2, and this is T3. If they form an arithmetic series, find x. Now we know for arithmetic series, so for arithmetic series, that D is equal to T2 minus T1, which equals T3 minus T2. So we're going to do T2 minus T1. So that's x plus 3 minus x is equal to T3 minus T2, which is 2x plus 5 minus, or take away, x plus 3. And now we solve for x. We've got x plus 3 minus x. We will just get 3 there. And we've got 2x minus x is x, and 5 minus 3 is plus 2. And so therefore x is equal to 1. So writing down the first three terms, so therefore the first three terms of the series would be, the first one's x, which is just a 1. Then the next one is x plus 3, which is 1 plus 3 is 4. The next one is 2x plus 5, which is 2 times 1 is 2 plus 5 is 7. So they're the first three terms of the series. And of course, the common difference, d, would be equal to 4 minus 1, which is 3, or also equal to 7 minus 4, which is 3, because I'm doing t2 minus t1 and t3 minus t2. Okay? We've looked at common difference. Now we're going to look at the terms of an arithmetic series. So if we have this arithmetic series here, first term is a, so that's t1. This is the second term, a plus d, so a plus a common difference d. And then this is the third term, a plus 2d, because it would be this a plus d here plus another d, which gives us a plus 2d. And this is the fourth term here, because we've got a plus d plus another d here, gives us a plus 3d. Now notice that the first term has no d. Term 2 has 1d. Term 3 has 2d. Term 2 has 1d. Term 3 has 2d. Term 4 has 3d. So the nth term, the number that's multiplied by the d is always 1 less than the n. So the last term, the nth term in this particular, or any nth term, sorry, would be a plus n minus 1d. Because when it's t4, you get 3d. When it's t3, you get 2d. So when it's tn, you'll get n minus 1d. So therefore, that is an arithmetic series with first term a, common difference d, okay? And nth term, tn equals a plus n minus 1d. So remember, this is the rule, the general rule that can be given to the series. You can use tn equals a plus n minus 1d to find any term in the series. Examples. So find the 15th term of this series below. So here we can see that this is our first term. So that's my first term, or t1, which is a, and my common difference d. Actually, I'll just write it normally. So first term, a is 120, and common difference d is t2 minus t1, which is 111 minus 120, which is negative 9. So it is going down by 9. I could have done t3 minus t2 is 102 minus 111, which is also negative 9. And I want the 15th term, so I'm evaluating the term when n is 15. So writing out the formula, tn equals a plus n minus 1d. And I'm just going to see where that is on the formula sheet. So on the first page of your formula sheet here, the mathematics formula sheet, we can see here nth term of an arithmetic series is tn equals a plus n minus 1d. So you don't have to learn it. It is there on your formula sheet, okay? And we'll be looking at all the rest of these in the videos to come. And so substituting these terms in, a is 120 plus n, if n is 15, n minus 1 is 15 minus 1, or I can just, now I should put t15, that's the 15th term, is 120 plus 15 minus 1 times the common difference is negative 9. So it's 120 plus 14 times negative 9. So therefore the 15th term is negative 6. Okay, so therefore the 15th term is negative 6. Now for another example. Another example, this one's using fractions. Find an expression for the nth term of the arithmetic series. Now we know here that a is 7/8, that's the first term. D, the common difference, is t2 minus t1, which is 1 minus 7/8, which is 1/8. Now, just checking, the series is going up, so the common difference will be positive. Or it could be t3 minus t2, which is 1 1/8 minus 1, which is 1/8. Okay, so if it's an arithmetic series, you only need to do one of them, t2 minus t1 or t3 minus t2. But if they're saying show that it's an arithmetic series, you'd need to show that t3 minus t2 equals t2. t2 minus t1 equals t3 minus t2. Okay, so we've got a is 7/8 and d is 1/8. So therefore, the nth term, tn equals a plus n minus 1d. So the nth term will be 7/8 plus n minus 1 times the common difference is 1/8. Okay, so you could then write that as tn equals 7/8 plus n minus 1 over 8, or that's fine there, or you could put the 1/8 in front, okay? We've got a common denominator of 8, and just adding two fractions with the same common denominator, so it would be 7 plus n minus 1 all over 8, which is n plus 6, or 6 plus n over 8. Example, which term of the series 1 plus 5 plus 9 all the way, or it goes on, continues, is equal to 213. Again, we can see that the first term A is 1. We can see the common difference. We can just see it, that it's 4, but you could do 5 minus 1 is 4, or 9 minus 5 is 4. So therefore, the general term Tn equals A plus n minus 1d. So we're just looking for the term that is 213. So 213 equals, so our term is 213. So 213 equals A, which is 1 plus n minus 1 times 4. So 213 equals 1 plus 4n minus 4. So 1 minus 4 is negative 3. So we get 216 equals 4n. So therefore n is 216 divided by 4, which is 54. Okay, so therefore the 54th term is equal to 213. Find the value of n, the first value of n, for which the terms of this series, negative 86, minus 83, minus 80, etc., minus etc., are positive. So again, A, the first term is negative 86. D, the common difference, we can see it's going up by 3. So it is 3, but you can do T2 minus T1, which is negative 83 minus negative 86, which is positive 3. It is getting bigger. So just because they're negative terms, don't assume that D is negative. So we know that Tn equals A plus n minus 1d. So the nth term is negative 86 plus n minus 1 times 3. We can put that 3 out the front of the n minus 1. So we want the first value of n for which this series is positive, so we need this. We basically want Tn to be greater than 0, and Tn is negative 86 plus 3 bracket n minus 1. That needs to be greater than 0, so taking this minus 86, adding 86, we get 3n plus 1 is greater than 86. We can just divide by 3 here, so 86 divided, actually we're not going to get a whole number there, so what I'm going to do, I'm going to expand actually. So I've got 3n minus 3 is greater than 86, so 3n is greater than, adding 3, we get 89. So therefore n is greater than 89 divided by 3, n is greater than, well, that would be 29 2/3, because 90 divided by 3 is 30. So therefore n must be 30. And just checking our answer, T30, here's my general equation, is negative 86 plus 3 times 30 minus 1. So it's negative 86 plus 3 times 29. Now 3 times 29 is 87, which is 1. So if you looked at the 29th term, you would get negative 2 if you were to put that in. Negative 86 plus 3 times 28, because you'd be doing 29 minus 1 is 28. You'd be getting negative 86 plus 84, which would be negative 2. So therefore this, the 30th term, is the first time value of n for which, so the answer is the 30th term. In other words, n is 30, gives the first positive value of the series. The next question is to find the 20th term of an arithmetic series with 4th term 29 and 10th term 83. So you've been given 2 bits of information. 4th term is 29 and 10th term is 83. So we're going to set up a set of simultaneous equations. So T4, we know that Tn equals A plus n minus 1d. So T4, the 4th term, will be A plus, now it'll be 4 minus 1, which is 3d. Okay, well, I'll put it in just to show you, 4 minus 1d. So T4 therefore is A plus 3d, equation 1. And we know that, and we also know that the 4th term is 29, so here we put 29 equals A plus 3d. We know that the 10th term, so T10, will be A plus 10 minus 1d, but we also know that that 10th term is 83, so 83 equals A plus 10 minus 1 is 9. a plus 9d. So we've got equation 1 and equation 2. We're going to solve simultaneously. We can see that if we subtract and do equation 2 minus 1, and I would do it that way you avoid negatives, we'll get 83 minus 29. 83 minus 29 is 54, a minus a is 0, and 9d minus 3d is 6d, so therefore d is 9. And once we've evaluated d, we can substitute that into, say, equation 1. Doesn't matter which one. So therefore 29 equals, d is 9. So 29 equals a plus 3 times d, which is 3 times 9. So 29 equals a plus 27, which means that a is 2. So therefore, our general term of our series is Tn equals a plus n minus 1d, which is 2 plus n minus 1, and d is 9. So that's the general term of the series. I like to put the 9 there in front. So a plus n minus 1d, because a was 2 and d was 9. So therefore the 20th term, finding the 20th term, is T20 when n is 20. 2 plus 9 times 20 minus 1 is 2 plus 9 times 19, which is, and the 20th term, that ends up being 173. I think we'll just do one more example. Okay, another example here is 0, a term of this series. Now with this series, a is 48, d, the common difference, well, it's going down, so going down by 3, common difference is negative 3. So Tn equals a plus n minus 1d. That's our arithmetic series. That's the general form. We want to see if 0 is a term. So 0 equals 48 plus n minus 1 times negative 3. That's a times there. So I'm going to go 48 minus 3 bracket n minus 1. So is 0 a term there? Well, so we've got, or I can just expand actually. Oh, yeah. So 0 equals 48 minus 3n plus 3. Just be careful here in your expansion. So therefore, taking this 3n over, we get 3n is 51. And so therefore, n is 17. So it does appear that 0, therefore, n is a whole number. So therefore, 0 is a term of the series. But if you got that n was not a whole number, so if n is not a whole number, then 0 would not have been a term of the series, okay? That was the last example, but I'm just doing another one or two. So show that log to the base 5 of x plus log to the base 5 of x squared plus log to the base 5 of x cubed is an arithmetic series. Now we know that for arithmetic series, d, t2 minus t1 will have to equal t3 minus t2. So let's look at t2 minus t1. That's log to the base 5 of x squared minus log to the base 5 of x, which is log to the base 5 using the log rules of x squared on x, which is log to the base 5 of x. Now, also looking at t3 minus t2. So it's not enough just to do t2 minus t1. For an arithmetic series, you're going to have to show that t2 minus t1 equals t3 minus t2. So t3 minus t2 is log to the base 5 of x cubed minus log to the base 5 of x squared, which is log to the base 5 using the log rules, which is log of a minus log of b, is log of a over b. So it's log to the base 5 of x cubed over x squared, which is log to the base 5 of x. So therefore, t2 minus t1 equals t3 minus t2. Therefore, it's an arithmetic series. I can put d equals, okay? And we can see here that the, I'll just do the next part of the example is to, let's just say we're asked to evaluate a particular term. So for example, evaluate the 80th term. So we know that Tn equals a plus n minus 1d. We know that a is log to the base 5 of x plus, now d is log to the base 5 of x as well, so it's log to the base 5 of x. I'm putting the d first and then the n minus 1. So that's Tn. So therefore the 80th term is log to the base 5 of x plus log to the base 5 of x times 80 minus 1 is 79. So these are like terms. So I'm going to put that 79 in front because it's log to the base 5 of x times 80 minus 1, which is 79. So it's log to the base 5 of x plus 79 log to the base 5 of x. These are like terms. So that's 80 log to the base 5 of x. Okay? All right. Actually, I might do that over the page. If x equals 4, evaluate the 10th term. So if x equals 4, evaluate the 10th term, Tn equals a plus n minus 1d, which was log to the base 5 of x plus log to the base 5 of x n minus 1. I'm just putting actually I'll leave it the other way around. Plus n minus 1 times log to the base 5 of x. So Tn, 10th term, T10 is log to the base 5 of x plus 10 minus 1 is 9 log to the base 5 of x. These are like terms. 1 log to the base 5 of x plus 9 log to the base 5 of x is 10 log to the base 5 of x. That's the expression for the 10th term. And when x is 4, we get the 10th term is 10 times log to the base 5 of 4. Now, we need change of base to evaluate that, because we can't enter log to the base 5 of 4 in our calculator, so it'll be 10 ln 5 over ln 4. And just doing that on the calculator, that is 11.6. Look, this actually is an example from the text, and their solution is 8.6. I really think that there's a typo error in it, because the 8 key is located, oh well, actually I'm not sure. Sorry, it's not located beneath the 11, but look, I've just double checked that, and I believe that the answer is 11.6.